Alright guys, let's take a look at page 329. We're going to start the last section of our exponential unit today, which means partner quiz and unit test coming up fairly soon. I'm thinking that our partner quiz is going to be on Thursday this week, and unit test towards the beginning of next week, probably Monday, Tuesday. Okay, so we're getting towards the end. This last section that we're going to go over today is by no means new content. It's more of a review type section where we're just going to very informally take a look at an equation, a table, a graph, okay, whatever we have available to us, and we're literally just going to try to pick apart any characteristic that we could possibly identify something about. Okay, so it's not really having guided questions here. It's more up to us to take a look at a piece of information and determine what do we know, what can we conclude. Okay, think about some of those characteristics. So the first one we're going to take a look at has a general equation for h of x at the top, and then they give us some table of values for different points that we know are on this particular exponential function graph. So I just want to see, okay, what can we identify as far as all those characteristics we've been talking about so far in this unit? How can we use the information provided to us to start to conclude some information about this exponential function? What might the graph look like? Can we figure out a, b, or c value? Can we classify growth or decay, increasing or decreasing? Can we do domain and range? Can we do transformations? Okay, all these different things we've been talking about in this unit. So let's just take a look at it and see kind of what we can notice first. I know it's a lot, but we got to start somewhere. Okay, Grace?
Is there a horizontal aspect to it?
Where? Okay.
-1.
Because?
Because the values are approaching -1, but they're not attaching to it.
Okay, because y values on left approach but not reach -1. I like it. Could we try to find another conclusion? Or maybe relate what Grace just said to the equation that they gave us? Can we make some connections? Good, Noah? Okay, so classification. Decreasing growth because?
Because as the x values get greater, the y values get farther negative, so that's how you know it's decreasing. And then growth because it's going away from the horizontal asymptote that we identified.
From number 1. Okay, so decreasing growth because right and behavior gets drastically negative and moves away from horizontal asymptote. Looking good so far. Picking apart little things. Let's find some more. Maybe, let's see, if we draw a little picture of decreasing growth, probably going to look something like that. You see something, Hadley? Yeah. Love it. All right, so in the equation, A is negative, less than 0 because graph is below horizontal asymptote. Okay, so now we're starting to actually make a connection here between what the table is telling us and how that is related to the equation. Okay, I think the first two that we listed were strictly table-based. And now we're starting to make that jump to the equation. Looking good. Can we find any more? So we just concluded something about the A value. Can we perhaps figure out something about the B value or the C value? What do you think, Caitlin? Okay. Looks good. Can we, maybe while we're on a roll, we said something about A, we said something about C, can we say something about B? We kind of had those two options, bigger than 1 or between 0 and 1. Logan, yeah?
I said between 0 and 1.
Because?
The original graph where it's less than 1 but greater than 0,
Mhm.
y-axis flip.
Okay, so the original basic graph is decreasing decay. So I'll label this basic. And then if we flip this, what was the flip you noticed?
Y-axis.
Y-axis flip, so that would move it left and right. How'd you know there was a y-axis?
So it was negative x and x.
All right, negative x in the power. So if we flip this left and right, it would look like this. We're getting there, bless you. Somehow, though, we already drew what the picture or graph should look like from the table. So we're getting there. Is there something else we can identify? What do you think? How'd you know there's an x-axis? Yeah. A is negative. Okay, that leading coefficient, that number out front's negative. So if we take this graph that Logan just showed us and flip it upside down, it's now underneath the x-axis with that decreasing growth. All right, so the only way to end with this shape, which is what the table is telling us, okay, the only way to end there is if we started with this decreasing growth basic graph. Because we have both flips. We have that negative x in the power and this negative leading coefficient out front. Okay, so base is somewhere between 0 and 1. I like it. Can we perhaps, now that we have a basic idea of what the graph could look like, can we determine domain and range? Do we have enough information from the table to determine how far left and right we go, how far low to high we go? What do you think, Caitlin? Yeah? Okay. -1. I like it. So we can go as far down as we want. That was that decreasing description that we had before. And we have to stop at the horizontal asymptote that we listed as -1. Looks good. All right, let's see if we can get a little bit more specific. So when we went to the A, B, and C information, we know what C is exactly, but maybe we can figure out A and B exactly. Yeah.
Can I borrow a pencil?
Yes. There you go. All right. Can we perhaps use the information from the table to figure out the exact number for A or B? Because we know what C is. Can we figure out these other two numbers? We already have an idea about what they should be, but let's see if we can get them exactly. Yeah. Okay, so if we have a calculator, you could type this into your stat, like L1, L2, and it'll generate an equation. That is limited, however, because your equation on your calculator always has a horizontal asymptote at 0. And notice how we said this one was at -1. So even though that is an option, it might not apply to this particular table. All right, which means if we're not going to use that aspect of a calculator, we should be able to do some of it at least by hand. Did you have an idea, Noah? I saw your hand go up. I guess not. Yeah.
Can't you avoid that by subtracting the HA from the y values? Like, since our HA is -1, if you add 1 to every y value and plug it in, you'll get the equation. And if you subtract 1 from that equation, you get the equation.
That might be an interesting experiment.
I tested it on a different one and it worked.
Did it work?
Yep.
So you subtracted -1,
Yes.
so you're adding 1 to all those.
Yeah.
Maybe we'll double check it. And you got the same base and the same A value. Okay, we'll check it out. That'll be a good testing one. All right, so we'll check out River's technique using the calculator. Can we figure it out by hand? That way we can double check our work with the calculator. Let's see, if we fill in the equation we have so far, we have h of x equals a times b to the negative x plus 2, and our c value we said was -1, -1. If we're going to solve for a or b, we kind of have to fill in something for these other variable spots. How can we do that? Good enough? Yes. I'll eventually have someone be able to help us out. Plug in a point. Okay, which point can we plug in? We have a lot available to us. 2, -2. Why do you want to strategically pick that one?
Because it's nice.
I heard a lot going on there. Because no decimals, which is nice. Okay, so maybe that's a little hint to use that one. If we plug this point in,
It cancels.
what cancels?
The exponent.
The exponent becomes 0, which we know has a property related to the base becoming a value of 1, meaning the b value actually goes away. So we're just going to be left with a out front. So add 1 over, we'll get -1. All right, notice how that fits our description from number 3. We said a should be negative, which it is, so we're probably doing something right. Can we figure out the b value? What do you think? Can we perhaps do something similar to what we did for A? Can we plug in another point? All right. What other point do you want to use? None of them. I know the other ones are pretty complicated, but we should probably be able to at least use one of them. Can you pick a nice one? This one? Okay, let's try it. All right, so y value, -1.001. A value, -1. B value, we're going to solve it. Power, -x plus 2. And C value, -1 on the end. All right, so solving for B, we'll add 1 over, so -0.001. Oh wait, I forgot the x value. If we're plugging in a -6, it'll change to a +6 because of the power. We can divide a negative over. And how can we get rid of a power of 8? We can do an 1/8 root. Okay, now on your calculator, if we hit the math button, we do have some options. Notice how number 4 is the cube root. It has that 3 kind of in the check mark spot. But if you select number 5 that has the x in the check mark spot, you can change that to any root you want. You just have to arrow over and kind of clear out that a and s that's in there now. And in this case, we'll just type in 8. And inside the root, what do we have? 0.001. So our base value is 0.42. All right, so now that we have the a, the b, and the c value, we should be able to write the full equation. -1 times 0.42 to the negative x plus 2 power minus 1. Kind of ran out of room.
Try making them all positive and moving it left too. Or so right too. So like.
All right, let's see. I think we can do perhaps one more thing. On Friday, we spent quite a bit of time talking about transformations and graphing these exponential functions. Now that we know the exact equation, can we label what the basic beginning equation was and then therefore list everything else as a transformation? What's the basic? If this is the whole equation, what did we initially start with? 0.42 to the x. Okay, just the base to a power. So everything else in there besides the base is some type of change. Can we list those? Down 1. X-axis flip because of the negative out front. Y-axis flip for the negative in the power spot. Yeah? Right 2 because of the +2 in the power, but it's also because of the negative in front of the x. All right, right 2. So based off those transformations, can we write the coordinate rule that was used to transform the points on this basic equation into the points that we have in the table? Can we think about how these transformations affect a variable? What do you think, Lainey? Okay, because of the flips, looks good. X-axis flips the y, y-axis flips or negates the x. All right, what about the right and down movements? You want to keep going, Lainey?
Add 2 to the x.
Okay. Subtract 1 from the y. Looks good. Okay. I would say that's pretty thorough and complete with basically everything we've gone over so far in this exponential unit. Now, River mentioned something interesting about using the table. Yeah?
It only works if the x in the exponent is just positive standard.
Mm-hmm. Okay.
It works if there's an AJ.
Gotcha. So I kind of thought about that after we mentioned doing it. You notice how when you type in an exponential function on your calculator, like use that table format, it says a times b to the x power. Now, what River mentioned is true. If you want to use your calculator to figure out an equation, you would have to get rid of that shift that's either up or down. So if your horizontal asymptote's at -1, bless you, you'd have to undo that. You'd have to add 1 to all these y values. The thing, however, that you don't have any control over changing is notice how the x on your calculator will always be positive, whereas the one in this equation has to be negative. So there are some ways to get around it, perhaps, but that's another case that we have to be careful to consider. Did you have an idea?
So like, what if you then swap what if you do the inverse of the x is negative and like swap all the y values to positive then?
Okay, so if you want to use your calculator, you're going to have to undo some of these. So you're going to have to undo the down 1, you're going to have to undo the y-axis, and you're going to have to undo the right 2 because that's not available in your calculator either. Okay, so you are able to do it, but there is going to be some work involved with that. All right, now that we kind of have an idea with what to look for, let's try another one. Okay, we'll flip the page. This time, we have an equation at the top, but instead of a table, we have a graph. So let's see if we can roll through some of these same characteristics, but just based off of some different pieces of information. So, where do we want to start? Good, Noah.
C equals 3.
Because?
That's where the horizontal asymptote is.
That's where your horizontal asymptote is. Okay. Anything else we can label about this exponential function? Okay, Caitlin? Increasing decay because?
It's going up towards the HA.
All right, right end behavior goes up while approaching horizontal asymptote. So the goes up part is the increasing, approaching horizontal asymptote is the decay. You have another one, Carter?
A is negative.
Because?
Below the horizontal asymptote.
There we go. All right, let's keep this well-oiled train going. Anything else? Let's see, we mentioned something about C, Carter just mentioned something about A. Can we perhaps label something about B? Okay, Caitlin? Because? Ooh, okay. There's no y-axis flip, okay? But there is an x-axis flip. We said that A out front's negative. That's kind of tricky. It's a little hidden. So there is a flip somewhere. Okay, that's an x-axis flip. So if we were to take this ending graph and flip it back, like undo this x-axis flip, the basic beginning one would look like this, which is that decreasing decay. So that would signify a base between 0 and 1. We'll say because x-axis flip. Okay. I think we also mentioned previously when we were doing all the patterns in that chart that if we have only one type of flip, that changes the increasing or decreasing nature. So if we only have 1, this increasing description would change to decreasing. So decreasing decay is that base between 0 and 1. I like it. Maybe now we can start to actually figure out the value for A and the value for B because we have some information to kind of help us check our work. So using the equation at the top and the graph that they have, how can we perhaps figure out one of those two? What do you think, Lainey? Okay, and why did you choose that specific point?
That will make the exponent 0.
There we go. All right, so we're going to strategically pick a point that makes the power 0. That way the base becomes 1 and essentially goes away. So we'll be left with A plus 3 in this case. So subtract the 3 over and we'll get negative 1. All right, A is less than 0, just like we anticipated. A might not always be negative 1, though. I know it was for the last example, but let's not get into the habit of just assuming it's going to be negative 1. Can we perhaps pick another point this time to help us figure out B? Preferably something nice. Go ahead, Caitlin. -6, -2. All right. So Y value -2, A value -1, B value we're going to find, X value -6, C value +3. All right, solving for B, let's subtract the 3 over, bless you. Divide the negative. B has a negative power. Where can we go from there? What do you think, Maggie? Say it again. All right, a negative power, we can flip the base, and that's going to make the power positive. I like it. So we get rid of a negative power, but notice how in turn that kind of makes it a fraction for us. How can we keep solving for B? I know it seems like we're creating more work for ourselves, but we are actually getting closer, which is good. If we have a variable in the bottom, we can, yep, we're going to multiply it over. All right, so now we can divide the 5, and we got to take the 4th root. All right, so again, on our calculator, if we hit the math option, go to number 5 that has the X, so you can put in any number you want. And we'll type in 1/5 on the inside of that 4th root. And we get 0.669. That's a base between 0 and 1 like we were anticipating, so I think we're doing something good. Let's write our final equation. H of x equals, let's see, -1 times 0.669, power x plus 2, C value 3. All right, I kind of ran a little bit out of room, but I'm going to move into the next block. That's okay. Now that we have the full equation, can we perhaps list some transformations or what the basic beginning equation was?
There's no x equals 0
Okay, Caitlin?
The basic is 0.669
To the x. Okay, so everything else in this equation is some type of change. Can we find them? x-axis, okay. Up 3. Left 2. Can we write the coordinate rule? How the x is affected, how the y is affected. What do you think, Lainey? Yep. Negative y plus 3. Almost done, guys. Hold on. All right, x minus 2, negative x plus 3. Last one. Domain and range. I don't think we've done that one yet. We actually have a graph, which helps. So you can drag your pencil. All real numbers. Shh. Range. 32, 3. There we go. All right. We'll call that a day. We'll check out the other 2 tomorrow, okay? But notice how this is like complete circle, okay? Totally encompassing everything that we've done with exponential functions since day 1.
It was sitting on your, you were like that. Like it was standing upright.